everybody has seen the robot move its arms from point A to point B, hopefully without hitting something, whether it's during interactive manipulation or pick and place. It works really well for the PR2. We're actively focused on making it work better. But today what I'm going to talk about is some work we've been doing to try to extend all of our successes in ARM navigation on the PR2 to sort of any arbitrary mobile manipulator in the community. So can we sort of make a suite of tools that makes it very clear sort of what our software can do, visualize all the components of the system, and make it really lightning fast to configure this thing to work on your new robot. And I'll say before I launch into the tools that a lot of the GUI prettiness is due to my intern, Matt Klingensmith, which that's been really great. Getting all of this away from in-curses, if you saw my last demonstration. Yeah, so the first tool that I'm going to show is, I think, the first wizard developed at Willow Garage. So the idea here is you have a robot and you have a physical description of the robot in the form of URDF, and you want it to do stuff. And you want to specifically look at our ARM navigation software and figure out how to get that working for you. And right now, we have a bunch of tutorials on the PR2. You can launch the simulator, you can dive in, but all of that's PR2 specific. We have this big nest of a stack with launch files and configuration. And it's really overwhelming when you start moving into that, trying to figure out what you need, what you don't need, what are all the components of the system, what do all these parameters mean. And I think that while we've had some successes in getting people to use it, the sort of app developers of the world, the hobbyists of the world, this is just going to be a lot to do. We're asking a lot from our users. So the idea is, well, what can we do to ask very little from our users, but to sort of configure an actual full-on ARM navigation application and then allow them to play with that ARM navigation application. So the first tool I'm going to show is the planning description configuration wizard. So all I'm passing into this is the URDF, so the physical description of the robot. What are the joints? How far can the joints move, so the joint limits? What are the set of links that make up the robot? And that can be a very accurate physical model, so very pretty meshes, all the way down to just blocks. So I'm going to use as our guinea pig Maxwell, which is sitting over in Mike Ferguson's office. You can poke it after this if you want to. So here is Maxwell. So this is an auto-configured RViz display. You can see that the actual Maxwell has a little bit more complex, URDF, but Mike is put together this block diagram, which is totally fine. That works great for as far as our purposes. So this is the actual wizard. We have our ornery turtle here. And so the first thing you'll see is we have easy and advanced. So the advanced allows you to twiddle a lot more things, to sort of define, to set configuration at a much finer level, but today we're only going to go through the easy mode. If anybody's interested in what the advanced mode does, then I'm happy to talk about that offline. So in the easy mode, I have to do one thing essentially, which is to say, what am I trying to navigate? What is the arm on this robot? Or what are the set of random joints on this robot that I'm actually going to be trying to execute plans for? And generally speaking, this is going to come in the form, for a mobile manipulator, in the form of a kinematic chain. So the set of links and joints, which is going to allow me to get my end effector somewhere in the world. So I'm going to add a group kinematic chain here. We have our helpful little diagram describing the different things I'm going to set. So this view actually allows me to navigate this tree structure of my robot. And I do need to know a little bit about what a kinematic chain is and why I'm setting this up to do this. And in this case, we're not going to focus on that. I do know the right things to specify for this robot. I give my chain a name, and then I say accept. And what this actually does is it brings up in RViz whatever I've set up. So we can see here that this is my arm. The green stuff is actually part of the kinematic chain, and the purple stuff is the end effector. So what I'm trying to get somewhere in the world so that I can pick something up. So we now have this visual confirmation that this is covering the entire arm, and it's not covering anything that's not in the arm. So with that done, I'm happy with that. And I can go back. So that was pretty hard, but that's all I have to do. So now I'm going to select a directory to drop. So this is actually going to drop a full application in here when I generate a config file. It's doing a ROS create package. It's putting together a whole bunch. It's auto-generating a bunch of parameters. It's auto-generating ROS launch XML and all of that great stuff. I hit this button and we're done. So that was the easy mode of the wizard. So let's see what comes from that. So now I have ARM navigation configured for my robot apparently. So I'm going to launch the second tool, which is called the Planning Components Visualization Wizard. So again, I now get Maxwell, but I also have a magic interact button. So what this allows me to do is I can now control my robot around using this interactive command. So in this mode, I'm in IK control mode. So I'm going to be dragging around those two little, I'm going to be dragging around the sort of tip of my end effector, and this is going to be solving IK and then producing the joint angles that result from that. So if I don't have a valid IK solution, it will show up as red. So I'm just dragging this guy around, and it all just kind of works. So Maxwell is a 5-duff arm, so there's a lot of places I'm not going to be able to reach in IK. For instance, if I move it over to the right, I get into a bad region, but I can just go to the last good state and get back there. So this is the IK control mode, which got auto-configured and is running for free running on my robot. We also implemented a joint control mode. So when I do this, it brings up. So this is, I get a control around each one of the degrees of freedom for my robot. And these actually...
Can you change the background color to like gray or something? Because the contrast is really bad.
Yeah, thanks for the...
Robots.
Okay, thanks guys. If there's anything else, I'm looking at my much better screen. So now I have each of these controls. And this control is respecting the joint limits, so I can't go past where you've told me that the joint can't physically go past. So I can get new positions there and move the robot in the world. So this is all great. So now I can set, so that was the in position. I can do the same thing for the start position. And I can do a combination of IK and joint control. That also works fine. And now I have automatically configured the planner. So the little ghostly yellow figure is just going from point A to point B. And we've made it pretty easy on ourselves. So all that it's avoiding now is just going from point A to point B without hitting itself. But that's, anything can do that. So we can add a pole to the environment, and we'll drag this up into an inconvenient location. Just to show that we can do this stuff too. So for about a couple minutes of work, now OMPL might, so we're using the back-end planner is a randomized sampling-based planner. It can occasionally do some kind of funky stuff, like that was maybe a little bit inefficient. I can also pass that resulting trajectory to a trajectory filter, which makes it smoother and potentially a little bit nicer. Okay, so that's sort of so for my couple minutes of work and configuration, I get a planner, I get IK for any of the groups I've set up, I get a trajectory filter, and I can sort of explore my robot URDF. So it's great that that works for Maxwell with its blocky meshes. I ran this on a bunch of different robots that all in easy mode, so not doing any of the advanced configuration. So this is Tone's Rosie, which we might have recently seen making a Bavarian breakfast, and which has the biggest, scariest hands in the entire world. So, there should be a bad projection. So there are the big, scary hands, and now I configured this with both groups, so I can switch back and forth between the groups. There's a handy other feature where I can just randomly perturb this and get a reasonable start state. So again, I can now solve IK, and plan, and filter, and so on. So this is showing the sort of planning components that still isn't all the way from getting your robot to actually avoid real stuff that it sensed in the environment, and it's not hooked up to a simulator, so you still need to do the work of actually like writing the controllers and having all of that. But in terms of the ARM navigation, this should be at least a baseline of everything you need to do. So this is almost to the point where this can do what PR2 ARM navigation can do, and you sort of didn't need to know about the nitty-gritty. And if you do want to learn about the nitty-gritty, you now have a full set of launch files. And if you want to twiddle parameters, then at least you know now what parameters to twiddle and what full components you can swap out to maybe get a little bit better performance for particular things. So this will all go out in eTurtle, we hope, and I hope that this means that many more mobile manipulators start using our software.